Good afternoon. My name is Dr. C. Thangapriya, Assistant Professor of Chemistry, the Standard Fireworks Rajarathinam College for Women, Sivakasi. So now I am going to discuss about the topic interhalogen compounds. So interhalogen compounds. So in this video we cover the introduction about the interhalogen compounds and its types. What are the types of interhalogen compound available and their formula, corresponding formula. So next we see how these interhalogen compounds are prepared. Then what is the structure of these interhalogen compounds. Finally we're going to see about the application in various fields. Interhalogen compounds. It is a covalent molecule. It is formed by the combination of two or more halogens combined together. We all know that halogen is in a periodic table. It belongs to the group 17. There is a halogens having the family members of fluorine, chlorine, bromine, iodine and astatine. So these are the elements present in the halogen family, and they are having the group number as group 17. So these interhalogen compounds is formed by combination of two or more halogens. That halogens may be of the same halogen or of different types. For example, the chlorine is combined with bromine, chlorine is combined with iodine to form these interhalogen compound. The formula for the interhalogen, that is generally it is represented as a X dash, where X is the electronegative atom of having the electronegative character higher compared to the X dash which having the lower electronegativity character. X is the electronegative atom which having the less electronegative character compared to the X dash which is having more electronegative character, but these two X are having the halogens group, belong to the halogens group. So now we see that types of interhalogen compounds. There are various types, 4 types available. First type is XY. XY having the formula, general formula is XY. The example for this XY is ICl, ClF3. So these are the example for this interhalogen compounds of the type XY. Similarly, XY3 type is also possible. The best example for this compound is BrF3, as well as for the type XY5, the example for this compound is BrF5. The last one type is XY7. Only one element is available for this XY7. The best example for this XY7 is IF7. So in the next slides we discuss about their structures and their application. These are the various interhalogen compounds. It is already prepared, and we discuss the properties, various properties of these interhalogen compounds, their boiling point, their solubility. These are the various properties we discuss in these interhalogen compounds. In addition to the interhalogen compound of the general type XX dash, similarly some binuclear compound is also formed, that is I2Cl6 compound is also formed in this. Next one, preparation method. Mainly to prepare the interhalogen compounds, 2 methods are recommended. The first method is direct mixing. Second method is reaction of halogens with other interhalogen compounds. What is the meaning for the direct mixing? That is, the direct mixing of halogens means directly we combined the 2 halogens atoms. 2 halogen molecules, for example chlorine Cl2 plus fluorine F2 combined at 473 Kelvin to form this 2ClF3 molecule. It is a interhalogen compounds. That is, chlorine is combined with the fluorine to form this type We already represent in the definition of the interhalogen compounds. That is the general formula for the interhalogen compound is XX dash, that is chlorine. Here chlorine is more electronegative compared to fluorine, which is combined with this fluorine. We cannot able to synthesis FCl3, that cannot be synthesis at all. Based on the definition, we synthesis only the ClF3 from this direct mixing of chlorine and fluorine molecule. This is the first method. Next we see the second method. In the second method, what we represent is reaction of halogens with other interhalogen compound. For example, if we want to prepare IF7, we represent this is a belong to the XY7 type. The only one compound is available for this XY7 type is this IF7. So how we prepare this compound? That is combining IF5, that is iodine pentafluoride is combined with this fluorine molecule to form this IF7 molecule. This is the one method of preparing the higher number of interhalogen compounds. So after preparing, they are studying the properties we already represent in the previous slides about the boiling point, density, density and solubility. These are all already we discussed. Now we discuss the shape of interhalogen compounds. There are various shapes possible depend on the type of the interhalogens involved in the type of interhalogens. So first we see the XY type. The example for this XY type is CLF. What is the shape of this CLF type is? The shape is a linear one. So we see the linear shape here. Next we see the XY3 type. For this XY3 type, we see the structure of CLF3. What is the shape of this CLF3 is? It is a T-shaped. So we see that T-shaped molecule. So in the T-shaped molecule, we see that two lone pair is available. That is, these two lone pair is available in the equatorial position. So these two lone pair is available in the equatorial position. We already know that during the bond formation, there are two types of bond. One is axial bond and another one is the equatorial bond. So for the formation of CLF3, these two lone pair is available in the two equatorial position. So the shape is T-shaped. Next we see the type BRF5. So in the BRF5, it is having the structure of square bromide. So which are having only one lone pair. So this only one lone pair is available in the axial position. In CLF3 it is present in the equatorial position, whereas in the BRF3 it is present in the axial position. So next we see the type IF7. So here is iodine is surrounded by 7 fluorine molecule. The shape of this geometry is pentagonal bipyramidal. There is no lone pair is available for this IF7 molecule. So here, in addition to the above structure we discussed, these are the some compounds. So they are having their shape BRF5. So the BRF5 having the two lone pair of electron. We already see the structure of the IF7, which having there is no lone pair is available for this IF7. So next we see about the application. In application, there are various application is available for this interhalogen compounds. The main application is they all act as a non-watery solvents. That is, if the compound is not able to dissolve in the water, these compounds are mostly solved in this interhalogen compound. So it is act as a non-watery solvent. Similarly, it is used in the catalyst for many reactions. One of the main compound, that is uranium hexafluoride. This uranium hexafluoride is used for the enrichment of uranium in the nuclear power plant. For the preparation of this uranium hexafluoride, it is prepared through this interhalogen compound. The uranium is combined with CLF3, which is give IFUF6 plus 3CLF. So finally it is act as a fluorinating compound. By adding fluorine to the particular compound, we can use this interhalogen compound. So these are the some application. So finally I thank you one and all So for listening this video, thank you.